Good morning, everyone. Welcome to the class of CE-333 Environmental Engineering 2. So, today we'll start this example problem. The example problem is based on the design of a gravity flow sanitary sewer. So, here you have been given this map. Can you see this, guys?
Yes, sir.
Yes,
And
sir.
I already discussed that there are different types of land usages like single family, college, shopping center, okay, and industrial park, etc. You have the road network and you have the control lines. Now, it's given that from a typical single family dwelling of land usage, the population density is 40% per hectare. Hmm. That means if these types of single family is 50 hectare, then total population will be 50 into 40. Now, wastewater flow is from these types of land usage is 380 liter per capita per day. That means one single person from these land usage produces 380 liter wastewater in a single day. Did I make it clear?
Yes, sir.
Okay. Number three is residential wastewater flow is given. Number four is commercial and industrial flows, right? Now, from commercial area, they have given that the wastewater flow is 20 meter cube per hectare per day. That means if you have industrial land area that is 100, then your wastewater flow will be 20 into 100. This is hectare, right? The hectare cancels out. Okay, so it will be meter cube per day. Clear?
Yes, sir.
Similarly, from industrial. Now, guys, if you look at here, this table varies from community to community. In Bangladesh, in Dhaka city, this is different. In British Columbia of Canada, it's different. In Sydney, Australia, it's different. So, uh, all this different, but it is not that much. I mean, drastically different, slightly different. Now, for Bangladesh here, if you go to the BNBC, okay, let me show you here. I mean, in the Bangladesh National Building Code, you they have provided this standards that how much wastewater can be generated from different types of land use facilities. Okay, and you should follow that. Let me show you this. Okay. This is maximum demand. This document is from BNBC, Bangladesh National Building Code. Okay. The recent one is 2020, but I'm using 2015 maybe. Anyway, so look at this table 8.5.1. 8.5.1 water consumption. Do you see? This is water consumption. That means what? Fresh water demand. This is fresh water demand, right? Are you following me? Can you see this?
Yes, sir.
Yes, sir.
So metropolitan city, city corporation area, district town, high income group, single family dwelling. Do you see single family dwelling? During the with full facility, they produce 260 liter per capita per day. Restricted facility, they produces 200 liter per capita per day, and it varies from different types of facilities. Okay, middle income group, low income group. Hmm. Sanitary drainage. To try to make you familiarize with this BNBC because when you become an engineer and you practice engineering in real life, you have to follow this Bangladesh National Building Code in designing say network or any other building design, structural design, okay, environmental engineering design. You have to follow this. So anyway, so what I wanted to show here to you is if you know the water demand from here, then you can take the wastewater as 90% or 95% of the, or maybe 100% of the water, freshwater supply. Okay. Now for institutional flow, what is institution, guys? Institution is a school, college. Okay. This is 400 meter cube per day. How? Um, there are 5,330 students. One student generates 75 liter per day. Okay, so and so you multiply this with this, and these are in liter. So if you convert it to meter cube, you have to divide it by 1,000. That's it. That's how you get 400 meter cube per day. Okay, clear.
Yes,
Yes,
sir.
sir.
For infiltration allowance, so remember again that our design flow is what? Peaking factor multiplied by Q average. No, Q average. These are the Q average. These are all Q average. These are all Q average. Okay. Plus infiltration. Plus if you have inflow. Plus if you have storm water. Then if it's a combined sewer, then there will be storm hot water. If it is separated sewer, then there will be no storm water. Okay. In this case, we are using separated sewer, so no storm water. Now infiltration, right? How can I calculate this? Let's look at this figure here. This figure gives us an estimation of the infiltration. If you have a service area of 100 hectare, for example, look at this figure. What is the area of single family homes A1? 200 hectare, am I right?
Yes, sir.
So if we want to calculate the infiltration for this area, then 100, 200, right? So here basically, yeah, okay, around 8 or 8.5, right?
Yes, sir.
Okay. Now you can see there are two sewers. One sewer, I mean, there are two lines. Number one A, number two B. Now this line is for old sewer, and if the sewer is old, then what would happen? There will be leakage, right? There will be leakage. Am I right?
Yes, sir.
So there will be higher infiltration or lower infiltration. Hmm? Would
Sir,
there be,
lower.
if there is leakage, if there is leakage, then higher infiltration or lower infiltration? Then the new pipe. In the new pipe, you don't have leakage much, right? Very small leakage. But in an old pipe, you have many leakages. Now tell me, infiltration will be higher in which pipe? Hmm? How does infiltration happens? Through the leakage. The infiltration will be higher in old pipe or new pipe.
Sir, old pipe.
Yeah, sir.
Hmm? Say it again.
Old pipe.
Old pipe. Why? Why?
Leakage will be there.
Because there are higher number of leakages,
Yes, sir.
more leakages, so more infiltration. So that's why this old sewer line is higher. Do you see? This line is higher than this line. The infiltration will be higher in old sewer. Okay. So you can calculate the infiltration rate meter cube per hectare per day. The reading here will come in meter cube per hectare per day. Okay, fine. Now see what they are saying here. For residential areas, obtain the peak infiltration values from the accompanying figure. Done. We have learned it. Now, for commercial, industrial, and institutional areas, also obtain the peak infiltration from the figure B also. But to make into account that the total length of sewers in these areas will generally be less than that in residential areas, use only 50% of the actual area to compute the infiltration allowance. What does that mean? That means um, let's take two areas. Okay, this is residential area. This is residential area. This is industrial area. Okay. Now, in residential area, typically there are higher number of buildings. Can you see, guys?
Yes, sir.
So there will be sewer lines going from here. In an industrial area, the facilities are generally larger. So what happens that the sewer line generally will be like this. Here is one. Here is one. So tell me one thing. Sewer length is higher in which type of area? Residential or industrial?
Residential.
Residential. Now, if pipe length is higher, then infiltration will also be higher within the same area. For example, they have same area, 100 hectare, 100 hectare. So, from the same amount of area, hmm, the infiltration will be higher in residential area because infiltration happens through the leakage of the pipe. Hmm, right?
Yes, sir.
So, if this is 100 hectare, this is also 100 hectare. So, from the ground, the water infiltrates, and if it gets the sewer with leakage, then there will be infiltration into the sewer. But if this is the ground and there is infiltration of the water, but there is no sewer, guys, there is no sewer, would there be infiltration in the pipe? This is this will directly go to the groundwater, maybe. Am I right?
Yes, sir.
That means, for example, here there is no pipe. So here there is no pipe. So although there is r- rainwater or precipitation, there will be no infiltration into the pipe because there is no pipe or sewer. That's why in industrial commercial area, the land available will be less. That means whatever you will, whatever the area you have, you'll have to use 50% of the actual area to compute infiltration allowance in case of uh, area which is other than the residential area. That means commercial area, industrial area in these cases. Did I make it clear?
Yes, sir.
Okay. Now peaking factor. How do you estimate peaking factor? For residential area, use the curve given in the accompanying figure. Use this figure. If you have a residential area with discharge equals to zero point 0.1, then use zero point 0.1, go to this figure, and your peaking factor will be 2.9. Okay. By the way, the graph here is this. Hmm, this is your graph, not this one. This is not the graph. This is the graph. Okay. Okay.
Yes,
Yes,
sir.
sir.
For commercial area, peaking factor is 1.8. For industrial area, is fixed 2.1. Institutional peaking point is 4. But for residential area, you have to use these graph. Why in institutional you have four picking factor, relatively higher than the others? The reason is institutional means school, college, university, and you can imagine that in an university there is a rush of people all on a sudden. Am I right?
Yes, sir.
So that's why you have a very high picking factor. Now this nomograph is very important. Okay, this nomograph gives you the opportunity to estimate the sewer components for a combination of different types of scenarios. We'll see this. Okay, we'll solve this inshallah. And of course using Manning's equation. Of course using Manning's equation and in full flow condition, assuming the sewer is in full flow condition. Clear?
Yes, sir.
Minimum pipe size. Usually this is 8 inch. Sometimes you may go as low as 6 inches. Minimum velocity, as I told you, this is 2.5 feet per second or 0.75 meter per second. Sometimes some community use zero point 0.6 meter per second. Okay, minimum cover. What is cover, guys? Cover is, this is the ground surface and this is the sewer. This is the ground surface and if this is the sewer, and the distance from the top of the sphere to the ground surface, this is 2 meter or 6 feet, 6.6 something. Clear, guys?
Yes, sir.
So solution. So far we saw the different components of the problem. Now let's start solving it one by one. Okay, step by step. First of all, first of all, lay out the structure. How? How? Following the road network and the control lines, right? So you need to know the map here. At first, you have to lay out the sewer. Here can see that this is higher elevation, and as you go downward, this is the lower elevation. So yes, and this is the road network. So you are laying out your sewer network in this direction, right, guys?
Yes, sir.
Okay. What else? Number two is locate and number the manholes. Okay. I already discussed with you the how to space the manholes, how to determine the location of the manholes. Okay. So as you can see, we have intersections here. So for now, let's assume we have a manhole here, we have a manhole here, here, all the junctions, right?
Yes, sir.
And we are designing the trunk sphere, and the main sphere will come from there to there. Main spheres will come from there to there. Let's make it a different color. Main sphere will come from there to there, there to there. These are the main spheres, okay? Right?
Yes, sir.
Okay. This is the trunk sphere, the red one, which one we're going to design. Now, look at and number the manholes. This is the intersection of the main sphere and the trunk sphere. So we are putting the manholes here. What's next? Locate and number the manholes. Locate manholes at. Okay. Change in direction. Changes in slope. Pipe junctions. Upper end sphere. Intervals from 90 to 120 meter or less. These guidelines I already discussed with you in detail in the previous section. For the purpose of this problem, only the manholes at the major junctions have been numbered. Figure A. That means here. In this case, it's numbers 1, 2, 3, 4, 5. These are the manhole numbers. Clear?
Yes, sir.
Yes, sir.
Again, this 1, 2, not this 2, not this one. Okay? This 1, 2, 3. These are the location of the manholes. This is the junction. Okay? 6, 7, 8, 9. These are the junctions. So, here is the junction. Okay? These are the location of the manholes. Preliminary, we have set them here. Prepare a sphere design computation table. So we need to make a table, okay? And then we will compute them one by one. Based on the experience of numerous engineers, it is found that the best approach for carrying out sphere computation is to use a computation table. You can do it in Excel, okay? This is the table. Actually, we have multiple tables. We'll see one by one. Okay. Now, look at this figure, guys. You have residential area, right?
Yes,
And
sir.
you have commercial area. You have college. That means institutional area. And if you go back, each of them has different peaking factors, right? Residential
Yes,
area
sir.
from this figure. Commercial area 1.8. Industrial area 2.1. Institutional school or college 4.0. That means you cannot you mix the table of residential and commercial or others. You have to make different tables for residential, commercial, industrial, and institutional. Separate tables. Okay, so that's why we have separated the tables. Let's look at the residential table first. You don't need to look at the line. You look at it from to from manhole. This is the column number. Okay, these are the column numbers. These are the column numbers. So from 1 to, this is column 1, column 2, column 3, column 4, column 5, column 6. Okay. Now this is what from to. What's that? This is actually this. If I tell you one from 1 to 2, if I tell you from 2, from 1 to 2, that means from this 1 to this 2. Clear?
Yes, sir.
That
Yes,
means
sir.
we are to referring to this pipe. Okay, fine. If I tell you 2 to 3, so 1 to 2 is actually this pipe. Okay. If I tell you 2 to 3, that means I'm referring to this 2 to this 3. So this pipe. 2 to 3. Clear?
Yes, sir.
Yes, sir.
1 to 2 means this 1 to 2, not this one, not this one, not this. Manhole. Okay, we are referring to manhole 1 to 2. So this 1 to this 2. 2 to 3. From manhole 2 to manhole 3. That means this 2 to this 3. Clear?
Yes, sir.
Yes, sir.
Okay. 1 to 2, 2 to 3, 3 to 4, 4 to 5. Like this. Now, from 1 to 2, that means which area? In this pipe from 1 to 2. Who is contributing, guys, in this pipe? Who is contributing in this pipe? Look at closely. Look at this arrow. Look at this arrow. Did you see? Who is contributing? This one. One means A1. So in this pipe, who is contributing? A1, right?
Yes, sir.
One, A2, and A3.
2 and 3. These 2 and 3. Where are they contributing, guys? Look at the point. At this point. But at this point, this pipe has already ended. This pipe has already ended. Am I right?
Yes, sir.
Here, 2 to 3 starts. So this A2 and A3 are not contributing to this pipe because at this point this pipe has already ended. So where are these A2 and A3 contributing? This A2 and A3 are contributing in this pipe 2 to 3, right?
Yes, sir.
So from 1 to 2 contributing area is A1. A1. From 2 to 3 contributing area is A2, A3. Who else, guys? Tell me who else in this pipe? Look at the arrows. A2, A3. So this wastewater will flow, 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 flow. Another arrow. Did you see here?
A5.
So A5 is contributing. Is A4 contributing in 2 to 3 this pipe?
No, sir.
Because at this point, this pipe has already ended. So A4 will contribute to 3 to 4, right? Clear?
Yes, sir.
Yes, sir.
So look at this 1 to 2, A1. From 2 to 3, A2, A3, A5. And then so on. Length of sewer 1 to 2. What is the length of sewer of this pipe? It's given. It's given. This is given 707 meter. Clear? It's given.
Yes, sir.
If you are using Google Earth, then you will be able to measure the length. Did I show you how to measure the elevation from Google Earth? Like a control line. Did I show you that?
जी सर.
Area, you already, sub area, we have identified these sub areas. Now, area hectare. For A1, this is what? This is 200 hectare. Okay? 200. Now, look at this. A2, A3, we have an area, right? But still, we didn't put this area here. Why? Because look at this. This is what? Residential. Residential. And A2, A3 is what? College. Is it residential?
No, sir.
Shopping center. Is it residential?
No, sir.
No sir.
So A2, A3 will not contribute here. Will contribute in this pipe. Yes, that's true. But we will not include this in the table. We'll include this in the table of commercial and institutional. Clear? Of
Yes.
course, they are contributing in this pipe, but we will not write this in this table. We will write this in the respective table. So A2, A3, we didn't put this here. A5, yes, this is residential, so this is 250. You'll see, okay? A2 is what? A2 is institutional, right? Let's see. This is commercial. Still, we didn't put A2. Did you see? This is industrial. Did we put A2? No. Nowhere we put A2. Where is the institution? Here. Now we are putting A2. Did you see? A2. You see this?
Yes, sir.
Okay. Anyway, let's go back to the residential area. So A8, this is also not residential. That's why we didn't put it. Okay. Now population density person per hectare. Let's see. A1 is what? A1 is single family homes. Hmm. If you go back to our question, single family homes. This. What is the population density? Saturation. Highest population density 40. Right?
Yes, sir.
Okay. 40. Clear?
Yes, sir.
Population increment persons. That means what? In one unit area, population is 40. Then 200 unit area, population will be 200 into 40. So this column 8 is multiplication of column 6 and column 7. That's why it's written 6 into 7. Clear?
Yes, sir.
Average unit flow. Average unit flow. What's that? This is what? A1 is what? Single family dwelling, right? One is what? Single family home, right? For
Yes, sir.
single family home, what is the wastewater flow per unit liter per capita per day? 380. 380. So that's why we have put 80 here. Similarly, for other types of residential area, you will put the average unit flow. Clear? This is the average. Okay? Clear?
Yes, sir.
Now, one person generates 380. Then 8,000 person generates what? 8,000 into 380, right?
Yes, sir.
So this column is actually 8 into 9. 8 into 9. Column number 8, column number 9. 3040. Clear?
Yes, sir.
Now, this is cumulative average flow. Cumulative, this is what? Average flow. This is also average. This is cumulative average. Cumulative means what? Summation of the previous one and the current one. All the previous one and the current one. That means in 1 to 2, 3040, 2 to 3, here we are not getting, we are getting, look at this. 3040. Do you have any flow here? No flow. So 3040. Do you have any flow here? 3040, no flow.
No, sir.
Do you have a flow here? Yes. 4375. That means this is what? 3040 plus 4375, 7415. Clear?
Yes, sir.
This physically, this means that this 2 to 3, this pipe, is going to have the contribution from A2, A3, A5, as well as the contribution from this pipe, because this pipe is flowing in this direction. Am I right?
Yes, sir.
So this 2 to 3 will get the contribution from pipe 1 also. Similarly, this pipe 3 to 4 is going to have the contribution from this pipe and this pipe, both. This pipe and this pipe, both. So that means starting from here, all the wastewater is gonna contribute in 3 to 4 and then 4 to 5 and so on. Okay. So that's why we have to take the cumulative one, cumulative average flow. 7415 plus 2640, 10,000 something. 10,000 something plus 4560, 14,000 something. Okay, clear.
Yes, sir.
Now, peaking factor 3040 meter cube per day. This is average, right? 3040 meter cube per day. Peaking factor, you have to go here. 3040 meter cube per day. Convert it to meter cube per second, guys. Convert it to meter cube per second. Tell me what's the value, please. 3040 meter cube per day. So if you convert it to meter cube per second, 3040 divided by 24 into 60 into 60. Tell me the value. Meter cube per second.
0.035.
0.035. So 0.035. 0.01, 0.02, 0.03, 0.04. 0.035 is here, right? It will be 2.8, maybe 2.7, something like that, right? All right.
Yes, sir.
Yes, sir.
I've taken 2.9. That's fine. 2.9. Okay. Clear.
Yes,
Yes,
sir.
sir.
So key peaking factor will be based on the cumulative average flow. Okay. Now cumulative peak flow will be peak flow will be 2.9 multiplied by 3040. Q average multiplied by peaking factor. This is the Q average. This is the peaking factor. So we have to multiply these two. That means column 11 and column 12. We have to multiply this. Get column 13. So 3040 multiplied by 2.9. This 3040 7415 multiplied by 2.7 20 something. Clear?
Yes, sir.
Yes, sir.
Okay. Now we have I have marked this. Look at this. 8 to 7. 5 to 6, 6 to 7, 8 to 7. There is a slight difference. Why this is happening? Because as you can see, the water is flowing from 8 to 7 here, right? From
Yes,
8
sir.
to 7. That's why you have written 8 to 7 and then 7 to 9. And in this 8 to 7, which area is contributing? 11. A11, right? Am I right?
Yes, sir.
Yes, sir.
Now, in this pipe, is the contribution from 6 to 7, 4 to 6, or 4 to 5, 5 to 6 coming? No, right? This
Yes,
pipe this pipe is not contributing into this pipe. No, no, no. This pipe is contributing into this pipe, but these pipes are not contributing here. 8 to 7. That's why we have written like 8 to 7. We did not we didn't part from the cumulative like 22,000 plus 308 got 3,800 plus no 22,000 plus 3,000 something, right? We didn't
yes, sir.
add it up. Did you see? This is 3,800. This is 3,800 because from 8 to 7 this pipe no one is contributing except A11. Is it clear to everyone?
Yes, sir.
Okay. Now from 7 to 9 Look at this. From 7 to 9 here in this pipe, everyone is contributing. This whole pipe is contributing as well as 8 to 7. This is also contributing, right? So that's why you have taken everything here. Look, this 22,000 something plus 3,800. That makes it 26,000. Clear?
Yes, sir.
A12. Why didn't you write A12 by the way? Because A12 is not a residential area. Is it? No, it's a residential area. So they have taken this. Maybe where? Ah, A12, right? Okay. A12. Let me check again.
আপনি 11 টা মার্ক করছেন।
Oh, yeah, sorry. From 7 to 9, who is contributing? 812. 812. So this is industrial. So this is not residential. That's why they didn't write it down. Clear? This is not residential. Clear to everyone?
Yes, sir.
So that's it. And now same calculation for the other types of land usages. We'll do it in the next class, inshallah. Any question, guys? No questions. Okay, then thank you very much. Have a good one and stay safe.